Hi, so I am going to show you thermal stress analysis, that is coupled analysis, thermal structural analysis. So that is how the thermal will be affected on the structure, right? So here steel link is given. Steel link is connected to the steel structure, solid structure. The solid structure is heated at 75 degrees Celsius, and the properties of the solid structure is that is steel link is given, that is modulus of elasticity 200 gigapascal, thermal conductivity is 60.5 watts per meter Kelvin, and the thermal expansion coefficient is 12 into 10 power minus 6 per Kelvin. This structure is heated for 75 degrees Celsius with a reference temperature of 0 degrees Celsius. So here we have to find out the expansion of a rod, that is a bar element, right, with respect to the temperature. So what is the procedure for solving this problem? First we have to write the thermal data and applying the boundary conditions of the problem, we have to save the file, right, that is in the name of a thermal or with reference name. And again we have to enter the structural data and save the structural file, and we have to read that thermal file for solving the thermal conditions. After that, the structural data are read for solving the problem with help of the thermal result, right, which is obtained in the thermal physics file, right. So and solving the structural file. So this is what the procedure for this problem, and this problem is taken from this website. So for this problem, I am selecting link 33 element, which is used for solving the structural analysis 2 with help of the thermal. This is actually a thermal problem, so which is able to conduct the heat between the two nodes, right? So it is also useful for solving the structural, right? So for that, I am selecting this node. So now preference, in the preference, we have to select the thermal, and next one is a add element, and in the element link 33. So this is a element, and in the real constant we have to add the area, which is 4 e power minus 4. The area is not given, I am assuming the area. And similarly the length of the bar is not given, that is also assumed. So now I am entering the material property of the thermal. So what is the conductivity? 60.5, right? And what is the modeling means? That is a line key point with the line creation, key point on the current coordinate system. So 1 0 play, and again 2 1. The length of the bar is not given, I am assuming as a 1 meter. Now line on active coordinate. So by selecting the 2 point, the line is generated. Now meshing. In the meshing, I am doing a manual mesh using the size control, manual size control. Select the all lines. That is, the division will be as a 20, right? And click mesh and select the line. Then click OK. So the mesh is generated, and come to the physics and write the file. That is important here. Thermal 6 is generated. Thermal is generated. Now again clear this environment. That is important. Then only the thermal data are cleared, but the file is saved. Now come to the element type. Switch element. Select the thermal to structural. Right. Now we have to do a material property, material model in the structural linear elastic isotropic. So we have to enter 200 e power 9, that is 200 gigapascal, which is given in the question. Yeah, and the Poisson ratio is 0.3, right? And the thermal expansion coefficient alpha 12 e power minus 6. Now we have to save this file, that is write struct. Okay. So now the thermal and the structural files are ready. So now click the list, you can see the thermal and structural file is created. The next file is created. Now come to the solution part. In the solution, before that, first we have to read this file. So read, select the thermal. Okay, now thermal is selected and come to the solution. In the solution, select define load, apply load in the thermal on key point. So this key point must be selected and with a temperature of 348 degrees Celsius. That is 75 degrees Celsius. Here I am giving as a 348 Kelvin, not as a temperature. Sorry, degree Celsius. And solve this file. This is what the thermal. So we solved this one and click finish. That is important. And again we have to go to the solution in the physics. Read structural file. Right now the structural data are ready for solving. So we have to apply the structural load. So here structural displacement on key point. So this key point is selected for all degree of freedom is arrested, and again this key point is selected for applying the boundary condition, that is ux is arrested. And with the help of the reference temperature, that is important. Here the reference temperature is 273 because we are applying in the Kelvin form. So 273 and temperature in the defined load we have to apply temperature, apply in the structural temperature, yeah, which is result from the that is a thermal analysis, from thermal analysis. So we have to select the thermal file, that is a file.rth. This is what the file. Just click OK. Now the thermal result is selected for solving the structural, and click the solve current ls. So solution is done. Now come to the general post processor. Click the element table, define the element table with help of the by sequence number ls load step number 1. Right, that means what are the stresses are generated. So this is what the result, and you can also see the hand calculation for this result, how the results are obtained. So we also see that one. So now the calculation part of this problem. So the expansion formula, that is thermal stress due to expansion of a bar. So that is delta is equal to alpha delta T L. So with help of this formula we can able to find out the stress value. So what is the stress value means for this problem we are getting 180 megapascal. So similarly here also our result is 180 megapascal, right? So 0.1800 E plus 0.9. So that is the same result we have obtained. So the units are different, that's why the condition. And why here the minus is because in the opposite direction. So here ANSYS it will take the direction sensitive, right? Thank you for watching.